Hi, in today's tutorial I want to talk about AWS Elastic Load Balancing, and then I will be using the classical load balancer to create a public internet facing load balancer and attach a back-end Amazon EC2 instances that are not publicly reachable. So these are EC2 instances that are using a private subnets, or basically a subnets without any public IPv4, a public DNS, or is attached to a gateway that has a default route to the internet. So Elastic Load Balancing supports three types of load balancer. We do have application load balancer, network load balancer, and a classical load balancer. In this tutorial, I will be discuss the classical load balancer. So what is a classical load balancer? A load balancer distributes incoming application traffic across multiple EC2 instances in multiple availability zones. This increases the fault tolerance of your applications. Elastic load balancing detects unhealthy instances and routes traffic only to healthy instances. Your load balancer serves as a single point of contact for clients. This increases the availability of your application. You can add and remove instances from your load balancer as you need, without disrupting the overall flow of the requests of your application. Elastic load balancing scales your load balancer as the traffic to your application changes over time. Elastic load balancing can scale to the vast majority of workloads automatically. A listener checks for connection requests from clients using the protocol and port that you configure, and forwards requests to one or more registered instances using the port and the protocol number that you configure. You can add one or more listener to your load balancer. You can configure health checks. A classical load balancer health check used to monitor the health of registered instances within your load balancer, so that the load balancer only sends requests to the healthy instances. So in this tutorial, I want to create a public internet facing load balancer, and this load balancer has two EC2 instances, and these are Apache web server 1, 2, and they are attached to a private subnet, so they are not publicly reachable. One is in availability zone B, let's say, and the other one in C. So here we see the user using his browser, typing in the virtual IP or the URL that the classical load balancer provides, and reaching the load balancer using the default port HTTP 80. So the inbound traffic coming to the load balancer, then the classical load balancer, which is publicly facing, distribute the internet traffic to these two instances. And we also have constant health check configured and provided by our classical load balancer. So the health check configuration contains information that a load balancer uses to determine the health state of the registered instances. So let's say web server 1 is down, so the Apache it's down, the traffic will be redistributed to web server 2, and so on, right? So here we have private subnets part, web server 1, web server 2 under the private subnets, and we have two public subnets under different availability zone for our classical load balancer. So we are going to create a virtual private cloud, adding our subnets, create an internet gateway for the public subnets to access the internet. We need also security group for both our classical load balancer to communicate with the EC2 instances, let's say we have to configure HTTP 80 for our security group on AWS. We also need a security group for our EC2 instances, and we need to create and run two Apache servers in our EC2 instances. And finally, we create the load balancer with all the configurations. So from the AWS Management Console, find services, type in VPC, and Virtual Private Cloud, select VPC. So here from the left side, select your VPCs, and I want to create a new one, create VPC, name this VPC, my ELB, and type in the IPv4 CIDR block 0.0.0.16, and then hit on create and close. So here I see my VPC successfully created for this tutorial. Now I want to go to, from the left side as well, go to subnets. So now I want to create 4 subnets. 2 are public for the ELB, for the Elastic load balancer, and 2 are private, and these 2 are going to be attached to my 2 EC2 instances, web server 1 and web server 2. So create subnet. Let me create a private subnet 1. Select your VPC, the one we just created. You see the name. Availability zone. In this case, you have to select availability zone B, US West, and make sure the other private subnet is on a different availability zone to apply the load balancer. And also you must configure the public subnet to be in the same availability zone as your private subnet. So let's say you created one private in B, you have to create one public in B, and so on. So I'm going to create one private in B, one private with another one in C. So in the public subnets, I'm going to create one in the availability zone B and the other public subnets in availability zone C. So here I have availability zone, and select the CIDR .0.0.0/27 for scalability, and hit on create. Now I have my first private subnet. I can create a new one. Let me create a private subnet 2. Select the same virtual private cloud. Availability zone, first one was B, the second one I'm going to select C, and the CIDR is 10.0.1.0/27. Hit on create, close this. So now I have 2 private for my EC2 instances, web server 1 and web server 2. Next, I want to create my public for the load balancer. Public subnet 1, virtual private cloud, the same. Availability, I'm going to select B, and CIDR block 10.0.2.0/27. Hit on create. And finally, I want to create the final second public subnet, right? So public subnet 2, the same virtual private cloud. Availability zone, this time C, and the CIDR block 10.0.3.0/27. So now I have 2 private and 2 public, right? Within the same virtual private cloud. So next, I want my load balancer to have access to the internet and provide an access to the HTTP to the end users. So I'm going to create an internet gateway and attach the two public subnets to this internet gateway with a default route. So from the left side, hit on internet gateways. Now here I can create my internet gateway by click internet gateway, and you can name your internet gateway here. So ELB, elastic load balancing, GW, gateway. Hit on create, close this. So now we have the gateway. However, it says the state is detached, so we need to attach it. Basically, we need to attach this gateway to a virtual private cloud, right? So click on actions, and here attach to a VPC and our new created virtual private cloud. So select your VPC here and click on attach. So now it says it's attached. So next I'm going to route tables, and I'm going to create a new route table. I'm going to call it ELB route table. Select your virtual private cloud and create. Close this. So select the route table, then going to route. As you see, this is a local target, so we need to edit the routes, add a route, and click on a default. So default route, and the target would be our gateway. So this is my gateway. Click on save routes, close this. Now going to subnet association. I'm going to select added subnet association, and I'm going to pick my two public subnets, which I'm going to use as a subnets for my load balancer. So I created public subnet 2 and public subnet 1. Click on save. So here is these two public subnet are now associated with this route table, and this route table now has access to the default route internet gateway. So if we go to summary, and we see associated with two subnets, and the routes, we have the local route and we have default route, and the target is the gateway. Next, I want to create my EC2 instances and have the web server or the Apache ready. So from services, select or type in EC2, select EC2, and here from the left side, instances, launch an instance. So here I'm going to select the my Amazon machine image. I already have two pre-configured Amazon Linux EC2 instance for this tutorial. So I have server 1, server 2 machine image, and if you don't know how to create an AMI, I already made a video and I will put it in the description. So I'm going to select number 1, and here I'm going to go next. Here I'm going to select my virtual private cloud, and the subnet I'm going to select private 1, and here I don't need public IP. Click on next for storage. Then optional tags, I'm going to name this instance, so name, and web server 1. Click on next. Security group, I don't need SSH. I can add HTTP port 80, review and launch, the key. I already have my key. If you don't have key, you can create a new key. So I'm launching this instance. So it successfully created my first web server. Now I'm going back and selecting my second one. So with the same configuration and settings, here select your private cloud, and subnet. For subnet, I'm going to select private subnet number 2, and this one no public IP. Click on next for the storage, default, and the name. I can add the key name and the value web server 2. Click on next. I don't need SSH. I'm going to add HTTP, and click on review on launch, and I have the key. So view instances. Now as you see, I do have the first one running, and I do have the second one on my private subnet. So now I have my 2 web servers, so 1 and 2. These are going to be used with my load balancer. Load balancers from the left side. Create a load balancer. I'm going to select a classic load balancer for my using EC2 classic network. So here I'm going to select my virtual private cloud, select the name, so here I'm going to, as you see for the load balancer, the port is by default 80 for HTTP. Here we have the subnets. We need to select 2 subnets. So we created 2 private for our EC2 instances, and now we are going to select the 2 public for the load balancer. So here I do have public 1. Click on the action and the plus sign, and I do have public subnet 2, right? So I'm going to select this one, and as you see now, I do have now in my load balancer 2 subnets, and then I do have 2 public subnets, and within different availability zones. So one is in 1B and the other one in 1C. So here we are going to assign the security group for this load balancer. Click on create a new security group, and security group name, I can call it my ELB security group, and by default we have port 80 as well to communicate with HTTP. So we leave it the way it is with port 80. Click next, configure security setting, and next configure health check. So for the health check, I'm going to leave these values as default. So in order to understand these values here, we have ping protocol, ping port, and the ping path. For the ping protocol, this is the protocol used to connect to the instance, which is TCP, HTTPS, or HTTP value. These are the valid values you can input here. We obviously have the ping port. This is the by default HTTP use port 80. You have a default value you can input from 1 to 65,535. These are the valid port range, and you have the path. This is the by default the index.html file for our Apache server. So if the path response other than 200 OK, this is the OK message, the instance is considered unhealthy. We have the response in the advanced details. We have response timeout. The response timeout option is in seconds, so here is 5 seconds, and this is the amount of time to wait when receiving a response from a health check. We also have the interval, so a health check interval. This is the amount of time between health check for each individual instance, and the values are from 5 seconds to 300 seconds. And we have the unhealthy threshold, and this is the number of failed health check that must occur before declaring an EC2 instance unhealthy. So by default we have 2, and the value is from 2 to 10 failed attempts before declaring that this EC2 instance or this EC2 that has the web server is bad. So it's redistribute the load balancer will redistribute the traffic to another EC2. So we also have the healthy threshold, and also these are numbers from valid from 2 to 10 attempts, and these are the number of successful health check that must occur before declaring an EC2 instance healthy. So 10 times before saying that our EC2 is healthy and we can distribute traffic to this web server. So click on next to add the EC2 instance. So here I have my both EC2 instances, web server 1 and web server 2, that I'm going to use with this load balancer. So we are going to basically distribute the network traffic between these two instances. So select both of them. We do have few options here, such as enable connection draining, enable cross-zone load balancing to distribute the network evenly. Click on next, tags, optional, review, and then create. So successfully created the load balancer, and here we see my load balancer. And if we go underneath here, we see the different tabs like description, like the name, the DNS name that we are going to use to type in our browser to check this load balancer. And we have the availability zone for this load balancer. We put two different availability zone, B and C instances. So it's out of service, takes a few minutes to be in service. And the listener, we have port 80. The health checks are the default value, and you can edit this values by click on edit health check, and we can monitor tags. Going back to the instances, we can do a refresh. So as you see now, the status of my both instances are in service. It means that they are healthy, and they are both, my load balancer is listening to the HTTP port. So going back to the description, you can use the DNS name record. Just basically copy this name, and going to a new tab from your browser. So here I'm going to paste it in the URL and hit enter. And as you see here, it says this is server 2. And if I click on refresh the page, server 1. So this is basically the network is the AWS is now basically distributing the traffic evenly between the two servers. So here we see server 1 going back to server 2, and this is the basically what I wrote inside the index.html, the basic file. So you see here the distribution of the network. It's for the end user. You will see the same DNS name. You're going to copy the same name or the public IP for the load balancer. But since we have two instances in the private nets, these network traffic is being distributed, so it's creating more availability and fault tolerance. And that should be it for this tutorial. I hope you enjoy it, and thank you so much for watching. Talk to you later. Bye.